All right, coming into the topics, we are done with transport layer. Firstly, application layer. We are done with these 5 layers.
Yeah.
So one thing, any doubts among these layers till now?
No.
No.
Okay, then we'll start with next
Yeah.
layer, which is layer 2, that is data link layer. So directly, firstly, if we talk about network layer, that is all about logical communication. Okay. Reason why I'm
Mhm.
saying it as logical communication is this is IP based. Now, if we talk about data link layer, the actual communication happens in this layer. With the help of MAC address. Now, MAC stands for media access control. Okay. If we talk about RPC, how to check the MAC address is go to the command prompt and type ipconfig. There you'll see your MAC address, your PC's MAC address. Again, this MAC address is the MAC address of NIC, Network Interface Card. And not ipconfig necessarily, it would be the command get MAC. Without spaces, just run the command get MAC in your command prompt. You'll get the MAC address of your device.
Okay.
So MAC address is also called as hardware address or physical address. Now let me snip it for you. Or else I'll do one thing. I'll share this one. Is this visible?
Yeah.
Command prompt. If you run the command get MAC, see on the left hand side you have the physical address. These are all the MAC addresses.
Okay.
Okay. So one moment. Not this one. Now, if we talk about MAC address, there are certain divisions involved. It cannot be manipulated or modified. Once once it is there, it would be there because that is hardware based address. Whenever a device is manufactured, at that point of time itself, the manufacturer assigns the address, which is called as hardware address or MAC address. One moment. Let me give you some detailed information about MAC address. Basically, basically this MAC address is of 48 bits. And how is it denoted as? Oops, I thought it is visible to you. Just a moment. Is this visible?
Yeah, it's
Yes.
visible.
Is embedded in the network interface card by the manufacturer. So according to bit standard that is actually embedded, that is embedded according to this standard, IEEE 802 standard, which, which is exactly an open standard. Open standard in the sense it is not specific to any vendor, meaning it is not specific to any company. Anyone can use it. Okay. But that is unique one. Meaning no one else can use the same MAC address. At a time, only one person will have it uniquely. So basically, this data link layer is divided into two sublayers. One would be this one, LLC sublayer. The other one would be MAC sublayer. So how the division takes place is depending on this diagram, if you see here. So this is again basically denoted by octaves. Okay. So 48, 48 bits is how many bytes? 6 bytes, correct?
Yeah.
Am I correct?
Yeah, 6 bytes.
Yeah.
One moment, there is some problem in mine. Are you able to hear me?
Yeah, we can hear you. But there is a background noise.
Clear now?
Yeah, it's clear now.
Okay. Think it this has been disconnected. Okay, no worries. So 6 bytes. Now each and every byte is considered as one octet over here. Just to understand it. Okay. 3 octets will be categorized under the category of organizationally unique identifier, which is the short form for that would be OUI. And the other 3 octets is called as network interface card, NIC, means network interface controller specific. So among these 3 octets, 8 bits, okay, 8 bits in the first octet, let's say bit 0 to bit 7. So bit 0 is for denotion of whether it is multicast address or whether it is unicast address. If it is 0, if it is not enabled, for example, bit 0 is not enabled, then that is called as unicast address. If bit 0 is enabled, meaning bit 0 is 1, then that is called as multicast MAC address. Okay, like I
Okay.
like I said, you have unicast address, but here in this cast MAC address. Unicast MAC address in the sense that is specific to one user, you can say. Okay, if it is multicast, that means for the group of users, one to many, right? One to specific.
Mm-hmm.
So whenever there is multicast IP address used, you'll use my multicast MAC address in layer 2. We are discussing layer 2 right now. So, and this is all about bit 0. If we talk about bit 1, for the bit 1 you have two things again. If it is 0, then it is called as globally unique. If it is 1, then it is called as locally administered, you can say. So why are these bits really important is whenever you take a Wireshark capture or something like that, or in order to understand how the device exactly understands that it is separated. Let's say if we are sending group of MAC addresses to the device, okay, how will it separate that exactly? Based on what values is this values? Am I clear? Based on these values, based on this bit values. And like I said earlier, these are deep drive informations, but nowhere you'll be asked. Just for your understanding, I am explaining this thing. Okay,
Okay.
just to know that how these are exactly differentiated. Okay,
Mm-hmm.
and especially organizationally unique identifier is the one which is uh, given by an organization. For specific organization, there is a reserved one with unique address. And one more thing, one moment. What was that thing is? Mm, I'm unable to understand how to copy it. No worries. I'll share the screen or I'll do one thing. Take it to another tab. Internet is responding a bit slow. One moment. Are you able to see the screen?
Yes.
Yes.
Okay, what I was explaining you is about organizational unique identifier. Please consider this as an additional information which I'm giving it to you. Okay.
Mm-hmm.
In fact, I don't remember anything, but I know how does it work. Okay. So firstly, it is denoted by hexadecimal format. Everyone knows that it's not a new thing. Okay. 6-byte binary number. And most of the times, depending on the vendor in the sense, depending on the company, for example, we have different company firewalls. Okay. So some companies, what they do is MAC address is denoted by this format. Okay. Um, 2 digits and 1 colon. But some companies, in case of, let's say, some companies, what they denote it as is uh, 2 digits with a hyphen in between them. So depending on the vendor, the MAC address format changes as according to their requirement. Like I said, okay, that is an open standard. Any company can use it. So depending on the requirement of the company customizes the MAC addresses. Okay,
Okay.
as per their requirement. Now, this unique identifier is given by the manufacturer. Now, prefixes means address. Here MAC prefix is there, right? Prefix is nothing but an address. Now, for example, these are the vendors. See Cisco, to identify Cisco, lastly, you will have this thing. To identify that Google, you have this thing. To identify HP, you have this thing. To identify Hawaii, just these are just examples. Like earlier, they used to denote it like this. I'm not sure how the Dell denotes. Whatever, just to understand, I'm explaining these things. Now, if we take this hexadecimal notation, like I said, depending on the vendor, some would be like this, some would be like this, some would be like this. See here.
Yeah. Dot.
Okay. This is the difference basically. All of them are called as MAC addresses, but their own customized MAC address as per their company's requirement. Is this thing clear?
Yeah. Clear.
Now,
Yeah.
there are different operating systems involved. If it is this colon hexadecimal notation is used by Linux OS. Okay,
Okay.
this denotation, this dot, this is called period separated hexadecimal notation. The last one, and it is used by Cisco systems, Cisco company. Now, what are the commands? If you want to check MAC address in your Linux, you can check with these commands. For Windows, you can check with these commands. For Mac OS, you have a panel called TCP IP control panel somewhere. Okay, you can check. I don't have Mac OS, so I am unaware of it. Now, these are very much important. Now, whatever we are going to discuss, unicast, like I said, type of MAC addresses, we have unicast one. How the device will get to know depending on that bit, which I was explaining you earlier, right? Whether it is unicast or multicast, how the device will get to know depending on that value, bit value, which I was explaining it to you. Now, this is specific to only one NIC card. One NIC card in the sense one port, you can say that. Okay. And if the LSB, least significant bit, I'll let you know where is it exactly least significant of the first octet is set to be 0. The one which I was showing you, right, bit 1, that is called as least significant bit. Okay, the frame and what was the PDU? PDU means protocol data unit in transport layer, if you remember. What is data exactly called in transport layer?
Fragments.
Fragments are in network layer.
Okay. Then packets.
No,
Okay.
segment,
Oh.
right? So in case of network layer, those are called as packets. But in case of
Okay.
Ethernet layer, those are called as frames. See
Okay.
here. Now,
So
unicast means, like I said, one to one. So one NIC card to one NIC card, one to one communication. A device can have multiple ports, right? For example, if I consider a switch might have 24 port, switch might have 48 port. Starting from 4 ports, 8 ports, 16 ports, it can have up to 48 ports. It can be more as well, depending on the switch vendor and its capability or capacity, you can say. Now, like there is unicast address, there is also a multicast address. Now, for this multicast address is called, meaning I'm discussing about, you can have multicast IP address, you can have multicast MAC address. Multicast IP address is actually required in which layer?
um, network
Network
layer.
layer. Multicast MAC address is required in. For that multicast IP address, I need to give multicast MAC address. For which multicast IP address? For which multicast address? For multicast IP address, I need to give multicast MAC address. So depending on what he is using, according to that IP, well, let me show you what are the multicast addresses first. There is a specific table for multicast addresses. You'll get to know it. For example, table. Not sure why the net is too slow today. Problem in loading the page. No worries. I'll take the example from here itself. I don't want to confuse you or something like that. Let it be as it is. No worries. So basically, you understand it in this manner. For example, this is a multicast address. Okay. Concentrate on last three octets and first three octets. Like I said, first three octets are organizational unique identifier. Okay. Depending on the organization, they have been given or they have been assigned. Next thing actually denotes what to which standardized group address it belongs to. And that thing you'll understand depending on the protocol. For example, VRRP. VRRP is the one. VRRP multicast address. See, this is the multicast address, multicast IP address. Okay. For this multicast IP address, you need to have multicast MAC address. So why you are actually giving multicast MAC address is because your packet is having multicast IP address. Wherever there is multicast IP address, you will need to have multicast MAC address for the multicast IP address. Only then you'll have multicast MAC address. If there is no multicast IP address, you will never have multicast MAC address over there. Am I clear?
Yeah, clear.
Uh, What is the reason? You might have a question. What is the reason? Like I said, IP is all about which communication? Logical communication.
Logical. Yeah.
If there is actual communication, only then logical communication is possible. Am I clear with this line?
Mm-hmm.
So the answer for my question, you'll find it very shortly, and you'll understand it how this actually is clubbed up with this hardware address or actual communication and logical communication, how they are interlinked, you'll get to know shortly. Those two are interlinked with the help of TCP IP. In case of TCP IP model, what happens is the OSI layers, some of the OSI layers are clubbed together to improve or for fast processing. Okay. At the back end, each and every layer functions individually, but as an overview, according to TCP IP, they have clubbed the layers, and after clubbing, what is happening basically inside PC as well, you will never see any OSI model concept. You'll only see TCP IP model. Okay, and it is basically called as TCP IP protocol suite. Am I clear with
Okay.
that line?
Mm-hmm.
So what is TCP IP? We'll understand it shortly. But for now,
Oh,
just as an overview, we are just discussing this concept. Okay. Now, where were we exactly? Yeah, we were discussing about this one. So basically, we are having three types of addresses: unicast, multicast, broadcast. So depending on the changing of that bit, now not only that bit, you see the broadcast, in which format is it in? This one. This broadcast address is called as the global broadcast address of layer 2
You're
by
not
default.
audible.
Am I not audible?
Like there was some disturbance.
Now is it clear?
It's clear.
Okay. So, well, this being secondary thing, one moment. Mm, no, man. Okay. Now let me explain it here itself. So, for example, you have, not for example, you have three addresses like I said: unicast MAC address, broadcast MAC address is denoted by all Fs. Generally, the MAC address is like this. This is in hexadecimal format. And now this, it can also be denoted in this format as well. Depending on the vendor. Am I clear?
Yes.
yeah.
This particular address is called Okay, layer 2 global broadcast address, meaning each and every layer 2 device, layer 2 in the sense whatever that each and every device will have layer 2 in it. So each and every device will understand what is this address all about.
Okay.
Now, if we talk about multicast address, depending on the multicast IP, so basically, oh my god, okay. So this address actually depends on what address is given in network layer. According to that address only, we'll assign multicast MAC address. Now, what is this unicast MAC address? It is very simple. Whatever we are using to each all other normal addresses. Let's say my PC is there. Okay, it is having some address, right? If my PC is communicating with any other device, for example, my PC will have its own MAC address. That PC, the other PC will have its own MAC address. The communication between these two PCs is with unicast MAC addresses, meaning there is no multicast. Are you are able to understand the meaning,
Yeah, yeah,
right?
yeah, yeah. So
Meaning
it's
one-to-one communication. Multicast means one to
multi-version.
specific. Broadcast means one to all.
One to all, yeah.
The same meaning I'm trying to convey, but technically with the help of MAC addresses. That is
Mac
the only
address.
thing. Don't be confused. Okay, the same
Yeah,
thing.
understood. Mm-hmm.
Okay. Now, well, this being said, let's search for Ethernet header. One moment. Let me pick Ethernet header. Ethernet header. Is this visible?
Yes.
Yeah, visible.
Okay. Now, firstly, you know what is this address, right?
Mm-hmm.
This as well. This is nothing but normal data. Now we need to understand what are these two and what is this one. Firstly, we'll understand what is FCS, frame check sequence. So normally what happens is, from destination's perspective, I'm explaining this frame check sequence. Where is that? Triangle. Yeah, here it is. As soon as the frame reaches here, this is the frame. So what happens to this frame? What is the requirement of frame check sequence here is he'll apply CRC algorithm, which is called firstly, you can remember it as just like a flow chart. Now, yesterday I have explained something with a cone, right? If you remember that diagram, for what? For cyclic
IP.
redundancy,
Okay.
CRC algorithm. How is it applied to a particular message? So in this case, take the same, let's consider the same example. What exactly happens is to the entire Ethernet frame, this algorithm is applied and a hash code is generated at which end? At the source end. Now,
Okay.
to that frame, this hash code which is generated is attached and sent to the destination device from the source. Okay. Now, what the destination device will do is it will separate that hash code and it will do the same thing. What thing? Once the frame is received, it separate the hash code. It will apply FCS CRC algorithm. Then if both the hash codes result, end result, if end result is matching the received value, then only it will proceed further. Let's say it is matching, then it will proceed with checking the destination MAC address. Let's say if it is not matched, then it will drop or discard the frame. Both are same, drop or discard. Okay. Am I clear, or you want me to explain it with another diagram?
No, it's
No, it's
clear.
clear actually.
Okay. The same thing basically, but depending on the layer, it is changing the way it functions. Okay.
Okay.
Now, one more thing I forgot to pick. Just a moment.
So this CRC algorithm is applied to every frame at every hop, right?
Every hop, meaning each and every device you are talking about?
Yeah, at link layer.
Correct. Exactly.
Okay.
Now, depending on how far the destination is, every time your layer to header would be changing. Reason
Yeah.
why it is changing, I'll explain
Okay.
later on, not now. As of now, you understand it up to header level only. Okay.
Okay.
Now, one moment. Where is this? Something I was searching for. Okay, I'll take a snip of it. I have one good document which I've got for you. So preamble and SFT are basically used to separate the frames on the wire. They are not included in the Ethernet header. They are just to separate the frames on the wire. Now, these two are clubbed together, but actually function individually. But as an overview, they two function together. Now, if you see the value over here, 101010, when it is 11, right? What it indicates
Okay.
is the next data which is coming is destination MAC. So firstly, in case of Ethernet frame, if you look carefully, you'll have destination MAC address. Then you'll have source MAC address. Okay. Am I clear on any confusion?
Oh, it's clear.
Okay. Firstly, you will have destination MAC address, then you'll have source MAC address, then followed by the length of the header, then data, then FCS. Now, in this case, 6 plus 6, 12, plus 2, 14, 14 plus 4, 18. Generally, Ethernet frame is of 18 bytes, okay, normally.
Mm-hmm.
Now, it is excluding which size? Excluding your
Data.
MTU. Okay, so including your MTU, how much it would be? 1518. Am I clear?
Yeah.
Yeah.
Again, your data size 46 to 1500 bytes. 46 plus 18, how much? 64, right?
64.
1500 plus 18, how much?
1518.
Okay, so minimum your frame size will be this much, which is 64. Maximum your frame size would be 1518. If it is less than this much, then the frame is dropped by saying that those are called as runts. RUNTS. If it is greater than 1518, then those are called as giants and they are dropped by default, I'm saying.
Okay.
One more thing I have mentioned, there are jumbo frames where as an exception they'll be ever allowed, but depending,
Yeah, they are used in Nexus. You
yeah.
actually told them yesterday.
So that jumbo frames is an exception over here. I'm talking about by default values. By default, they won't allow anything. Am I clear? Until and unless you allow it.
Okay.
This thing is clear, right?
Yeah, it's clear.
Okay.
Yes.
Now, frame check sequence is clear, data is clear. Now, this 2 byte value, one moment. Okay. Yeah. Okay, just a second. Where is that? Where is that? This 2 bytes is indicating which length is. Mm, 2 bytes is how much? 1 byte is equal to 8 bits, right?
16 bits.
Yeah.
Yeah.
2 bytes is 16 bits, right? So 16 bits means 2 power 16 is how much?
65.
So maximum length of this one could be this much, along with the support of what it is mentioning along with the support is um, 0 to 65534, but actually the length cannot be larger than 1500 because of some own limitations of Ethernet. Some own limitations of Ethernet is MTU value. Normally
Okay.
what, as per that length byte, how much the size should go? 0 to 65535, you can say that, but it cannot exceed the value of MTU officially. So maximum allowed limit is 1518. Beyond that, it cannot go.
Okay.
So this is the limitation part. And there should be another value. The thing which I've explained just now is 802 header as per IEEE standard 802.3 Ethernet frame format. Okay, now we have another frame format which is one moment, let me snip it for you. Where is that? Where is that paint? Okay, now this is called as, one moment, Ethernet. Uh, where is to value? I can say II to header. So normally your frame size is 18 bytes only, Ethernet frame size. Now in this case, what happens is to this entire frame, to this entire thing, your FCS is added algorithm, and it will generate a hash code. Normal considering values, this is called as destination service access point. This is called as source service access point. This is called as control. This is data. This type. What is this type is? You remember protocol in IP header? Something we discussed protocol yesterday. Do we remember
Yeah.
that?
Mm-hmm.
What does it do? The type of traffic encapsulated inside the packet.
Like TCP, UDP, right?
Yes, correct. In the
Okay.
same way, we have the type of traffic encapsulated inside the frame, meaning who has given that one means whom to hand over the remaining payload. if I need to hand over to IPv4, I'll attach this hexadecimal value. If I need to hand over to IPv6, I will attach this value. These are hexadecimal values. There is another protocol called as ARP. If it is ARP, then it is 0x0806. Basically, this is the thing regarding the type. Okay, so normally what are the fields inside your Ethernet header is type. Okay, and it will be something called FCS and then data. So you know what is FCS? These are the things which have to be filled depending on the type. You'll understand. And fields inside the IP header, how you'll explain it to interviewer or how you will remember is in this manner. So IP header means source IP, destination IP, protocol, then ETL. Am I clear?
Yeah.
Yeah.
If it is for TCP, then source port, destination port, your flags, whatever, then window size. But basically we denote like this only. Source and destination port should be enough. Remember one thing always, source port is what? Random number. Coming to destination port, so this is basically for TCP, sorry, transport layer. Be it TCP, be it UDP, you'll have source port and destination port. Okay. And this is what IPv4 header. This is Ethernet header. Now, this was all about data link layer. It is nothing but where the actual communication happens. Correct? Only it can detect error is there. If error is there, what it'll do? It'll drop or discard the frame. Correct?
Mm-hmm.
But in case of transport layer,
It
if
will
error is there,
resend like.
retransmission happens. So
Uh-huh.
in case of transport layer, error detection and correction both happens. Sorry, in case of TCP, you can say.
Yeah, TCP.
Okay. Now, the last layer of OSI, which is physical layer. In this layer, what happens is, this is all about let's say frame is bits. Frame is converted into bits in this layer. Okay. Now, form of is this thing clear?
Yeah.
If it is wired connection, normal wire like Ethernet, okay, then the bits are transmitted in the form of electrical signals in the wire. Now, if it is a wireless connection, in that case, the bits are transmitted in the form of radio waves. If it is a fiber optic connection, then the bits are transmitted in the form of light waves. Okay.
Okay.
Now, this layer is all about cables, physical cables. Okay. Now, what are the types of cables we have? Crossover cable and straight through cable. One moment, let me pull out the diagram for you. Not diagram, means physically how they look. Mm, okay, okay, open. I'm sorry about the slow internet connectivity. Not sure what happened today. Mm, okay, no worries. I'll take this snip. Come on, man. Yeah. So this is basically straight through, and this is basically crossover. If you see the division in between these two, okay, oops, what what are you able to understand? Which is the cable which is used to connect same devices, and what is the cable which is used to connect different devices, according to you?
Same device is crossover, I think.
Correct. See here, PC and PC. Here you have PC and some other device which is called as hub. So in order to connect different devices, we have straight through cable. For connecting crossover cable. Now, there are pin configurations in this. There are 8 pins on each of the device. Okay. Now, in this 8 pins, 2 pins are for transmitting, 2 pins are for receiving. Rest of the pins are all reserved or unused, you can say. Okay. Basically, those are unused. If you want to use them, you can use it, but not really they'll be into use. Am I clear?
Okay,
Now, this
clear.
transmit plus is connected to receive plus. I'm talking about straight through cable over here. Transmit plus is connected to receive plus, transmit
Mhm.
minus to receive minus, receive plus to transmit plus, receive minus to transmit minus. Green, blue, orange. See here, there are some color codes actually. Orange, white, some color codes are there. I don't remember it right now. Okay, there are certain color codes for the cables which are necessary actually. This is only necessary when you'll work in. Am I clear?
Okay.
Data center with physical boxes. There you need to understand what is cable, how you need to actually divide those cables, what cable you will use for same devices, what cable you'll use for different devices. And apart from these two, one more thing I forgot to explain. Yeah, crossover cable. In this crossover cable, if you see PC to PC, same device communication, transmit plus is connected to receive plus, but this receive plus is in which pin? Pin number 3. But in case of straight
Straight
through
through
cable, see it is in
in
pin
one.
number 1. So basically they use same color codes but different devices. Okay, I can say like this. Color codes at what end? At both the ends, you can say. Same color codes but to connect to different devices. But in this case, it is different. It is in reverse manner. Different color codes. Okay. Now, There is another cable which is called as okay. This console cable is used to take console access of the device. Console port of a device. Okay. Now I'd like to show you the images. Just for your understanding, I'm showing that image. Okay. Console cable. New snap. Are you able to see this thing? This is called console cable. Okay.
Okay.
Serial to USB. I'm sorry, serial to RJ45. This is serial.
Okay.
This one is called serial. Okay. And this port, this is plugged into RJ45. One moment. Who is this? I just want to lower the value on the laptop. Okay. Now this is RJ45, serial to RJ45. This serial is plugged into your laptop. This RJ45 is plugged into the console port of a device. Now, for example, any device, what device should I take for you? Okay. Let's say router console port. So basically, okay, this image should be good example for you. Where is that? Are you able to see this?
Yeah.
So here is the console port. It is Cisco Catalyst 2960 switch basically. Okay. Now see this is the console port. Basically this RJ45 is plugged in over here and this serial is plugged into your laptop. Okay. So this is how you'll take the console access of the device. Am I clear?
Yeah.
Now we are done with OSI model. Now we'll understand the difference between OSI, how OSI has been advanced to TCP/IP. So OSI model, in case of OSI model, you have 7 different layers. One, start from top to top to bottom. Application, sorry. Layer 6 is presentation. So in case of TCP IP model, how the advancement came with OSIs, they have clubbed these two, and they have clubbed these two. They have clubbed these three, and they call that layer as, okay. Now for them, this layer is called as, and for them, this layer is called as, and the last layer, they've clubbed these two, and they are called, they are calling that layer as, clear? So in case of TCP IP, we have only 4 layers. Now, basic functionality of each and every device is depend on TCP IP model, but not depending on OSI model. But at the backend, definitely OSI is there. Only then TCP is there. But for us, as a visibility, only TCP IP model is visible. How am I saying only TCP IP model is visible? If you saw that Wireshark which I opened, right?
Yeah,
You remember?
yeah, remembered.
Yeah.
Uh, did you see all the layers over there? No, right? Only some
No.
of them were visible. So basically, this is TCP/IP protocol suite which is followed actually. So that is the only reason why you're seeing that one as a limited
Okay.
layers. Okay. One moment. Let me open this. Any one of the thing. Remind me later. Stop this capture. Internet to frame. Now, in Wireshark, you saw those. Actually, header begins in which layer?
Um, Transport
Yeah,
application.
header begins from transport layer only. Okay,
Okay.
so that is the reason why in case of Wireshark, you are seeing from transport layer, then followed by network layer, then
Network
followed
layer.
by Ethernet, then followed by bits in the physical layer. Okay,
Mm-hmm.
so why I was calling transport layer as the heart of OSI model? Now do you understand? Because
Okay.
this is the only layer where you have error detection and correction. This is the only layer where you have reliability. This is the only layer where you have retransmissions. This is the only layer where you have agreements,
Okay.
uniform data transfer. Even if there is a congestion in between, this is the only layer where you have control. Am I clear?
Yeah. Understood.
So, so
Yeah.
that is the reason why it is called as heart of the OSI model. Now, mm, let me share you my main screen. So if you, these windows are ncpa.cpl. Oops, sorry about that. If you run this one, you'll be redirected to network adapters. Now I'll go and right click on this Wi-Fi adapter. I'll click on status details. If you see this, these are all, not only this, one moment. I'll click on properties. You will have this one. See, Internet Protocol version 4 TCP IP. Okay. If you double click on it, this is where you'll assign your IP addresses. Now, IP address can be assigned automatically or it can be assigned manually. If you click here, you can assign your IP address manually. If you click here, this means automatically IP address will come over here. Am I clear?
Yeah, it's clear.
Okay. Now, this is called APIPA, automatic private IP address. So basically, this APIPA IP address is used where you have assigned an IP address to obtain automatically, but unfortunately due to some reasons, if automatic IP address is not been assigned, then in that case it will pick some APIPA IP address. Okay, that scenario I'll show you practically. Like this you will not understand. Okay, when we start the practicals you'll understand that thing, but for now why I have opened this is to make you understand that we are working on, sorry, each and every device is working on TCP IP protocol suite. Am I clear?
Yeah.
Yeah.
Transmission control protocol / internet protocol. Okay,
Mhm.
now apart from this, okay, now we'll discuss a small flow. For example, I have this PC and I am taking remote access of this particular server. I'm just connecting a switch in between. Basically, all of them are in the same network. This is my PC. Now we are entering into real world scenarios, okay?
Okay.
With OSI, with the help of OSI, how the troubleshooting needs to be done, you'll understand here. Server. Now, whatever the server it is, now I want to take remote access of this server from my PC. Let's say the PC's IP address is 10.111/24. Server's IP address is, both are in the same network. Okay. So there is no requirement of which device.
Router.
Correct. Now, usually this will not be the case. Definitely a firewall or some other device would be involved in order to secure the server. I cannot give access of the server directly to this particular user. User can generate an attack and launch it on this particular server. So servers are always sensitive devices. In order to protect the servers, they are always behind the firewall. Am I
Okay.
clear?
Mm-hmm.
Okay. Now, in this case, we'll understand the OSI flow, how it'll be generated. Now, I want to take, for simplicity, let's go with basic. I want to take the telnet access. Now, the question is how you'll take the telnet access. You're able to see my PC screen, right? What I'm
Yes.
typing.
Yeah.
This is called putty. Okay,
Mm-hmm.
here you will have here you have different connection type protocols. These are protocols. Okay, this is remote login, this is raw login, this is telnet, this is serial. Whenever you connect serial cable, right,
Yeah.
There you need to select this option. If you select this would be some speed or something will come. If you're taking SSH, you'll have port 22. If you're taking Telnet, you'll have port 23. You'll just enter your IP address here. At the back end, you'll be redirected to many things. Okay.
Okay. Mm-hmm.
How the flow is happening right now, I'll make you understand, but this is one of the tool for taking remote access. Okay. Just you need to
Okay.
enter the IP address over here and then a particular port number. Basically, Telnet uses the port number of 23. Okay. Now close this or cancel this. Telnet port number 23. Telnet is which layer protocol?
Internet protocol or uh,
I have mentioned some
transport?
lines. If it is, sorry about that. If it is an application layer protocol, only then you'll have what? Port numbers,
Okay.
correct? If it
Mm-hmm.
is not an application layer protocol, then what is the requirement of transport layer in between? Correct?
Okay.
So Telnet is an application layer protocol. Fine. Now, since Telnet is an application layer protocol, it will definitely have a port number. Now,
Okay.
one more thing to be remembered. Telnet uses which protocol at transport layer? That has also to be taken into consideration. That should also be taken into the consideration. Okay.
Okay.
So whatever we have discussed so far, how those concepts will be applied practically is the thing which I'm showing you here. Okay. So each and
Okay.
every concept will be brushed up over here depending on the protocol which you are using and depending on the service which you are using. Now we'll start from application layer. But firstly, like the way I said, if it is application layer protocol, only then you'll have port number. This
Port
is
numbers.
important line to remember. Okay. Now this PC, what it is doing from the applications layer perspective, it is asking for a service, right? From what? From server.
So
Which
okay.
service is it asking for? Remote service it is asking for. Am I clear?
Mm-hmm.
So now it is definitely proven that which layer protocol? Telnet is
Application.
application layer protocol for
Application
sure.
layer.
Because it is expecting remote service from this particular server.
So
Sorry,
okay.
remote service. Fine. Now, at the application layer, do we have any header?
No.
No.
We have what?
Data.
Correct. Data. So we have this thing. I am considering that as normal, just simplicity. Now, like I said, do we use any OSI? We use OSI at the backend, but for us, what is visible?
Uh,
TCP IP.
TCP API.
So correct, right? So,
Mm-hmm.
but we'll go with backend process as well, which is not visible. Okay. Now, at the application layer, we have generated some data. Okay. That data is nothing but a protocol, which is telnet. Now, this telnet is at what layer? Layer 7. Now, when it is hand over to layer 6, what is the job of layer 6?
To create a session.
Layer 6. What is layer
Okay,
6?
presentation layer, right?
Yes.
Okay. So it converts the below layer like
Standard format.
yes, to standard format, right? Like
Okay.
ASCII.
Okay, correct.
Right?
So here, since telnet is a plain text data, okay, there is
Mhm.
no requirement of any conversion, encryption, decryption, compression, decompression, or something like that. Okay.
Okay.
Presentation layer does encryption, decryption, compression, decompression. Whatever he can do, he'll do. Okay. Presentation layer is to just like screwing the data in its own manner. Okay. So there
Okay.
is no requirement of any conversion. So it is in plain text only, right? Now,
Okay.
after this, it will go to which layer?
Layer
Layer
5.
5. Session layer will, what it will do? Create the
Create a session.
session. Now, which session will it create? Definitely full duplex, right?
Okay.
Now, after this, layer 4, what happens?
So
Transport. Like
it
uh,
uses either a UDP or TCP,
In this case, what it should use?
TCP.
telnet, TCP.
Okay, TCP it will use. TCP will have its headers information, so definitely it will attach source
Source
port.
port and
Which number?
destination.
Random
Number.
number,
Yeah.
correct?
23. Destination.
Correct. Destination port is well-known number, which is 23.
23.
Now here, what happens in this layer?
It creates segments.
Three-way handshake happens, right?
Okay. Okay. Yeah.
Now in the three-way handshake, it will carry only this thing, but it won't carry exact telnet data. Okay,
Mm-hmm.
it will carry only port number, source port, destination port with SYN flag enabled. Correct.
Yeah.
So SYN goes, SYN ACK comes back,
Comes.
then ACK.
Acknowledge. Okay.
Once this is done, actual data, telnet, is wrapped. Okay, with what? Sorry, telnet is encapsulated. So firstly, let's assume like this. Telnet, then transport layer header. TCP header. Okay, you should know the fields. No worries. For now, I'll have only these two fields. I'm considering that way. Fine.
Okay.
Now, this is what? This is segment. This segment will come to which layer?
Network layer.
Network layer. Now in network layer, I'm calling this as segment. Okay. Now along with this segment, what is attached? What is the source IP? 10.1, right? For simplicity, I'm writing it as like this. What is the destination IP? It is
23.
10.2, right? Here it is.
Uh,
10.1.12. Okay. Now, after that, what is the protocol value?
IPv4 it is 8. Is it?
It is there in IP layer. From where IPv4 came? IP is
Oh,
encapsulating it, right? So
in
protocol
yeah, okay.
value. What is there in the segment?
Uh, TCP header. So
So TCP, right? So which
TCP, yeah,
protocol value? What is the value? 6, right? For
6.
TCP.
Yeah, okay. Mm-hmm.
Now, another fleet, TTL. What should be the TTL? I'm considering
Uh,
that as Windows PC. So it should be
so
128.
128. Yeah,
Now, what is this thing called as?
segment.
How come this is segment? This should be packet, right?
Uh,
IP header is there. In layer 3, it is packet, right?
okay, okay. So in layer 4, it is segment, right?
Yes.
Okay,
Segment has
okay.
come here.
Okay, okay. All right.
Clear?
Mm-hmm.
Now, this packet will be hand over to
Link layer, layer
data
2.
link layer. Now, this packet has come to data link layer. Now, once the packet is arrived, data link layer will encapsulate its header,
Uh,
right?
yeah. Mm-hmm.
So what are the fields? Source MAC. What would be the source MAC? Some MAC address which is in
Private address.
hexadecimal format, which is PC MAC address,
Yeah.
correct?
Mm-hmm.
What would be the destination MAC?
So it should be switches.
Switch doesn't have any MAC. Server MAC address.
Okay. Okay. Yeah. Mm-hmm.
Then other thing I mentioned something called type. In this packet is given by which protocol in network layer?
TCP. IPv4. Yeah. Sorry. IPv4.
If it is IPv4, I told some value
Yeah.
0x
0x
E
800.
double zero. So what is this entire thing called now?
Frame.
Yes. So this is the frame. Now this frame is hand over to, sorry, layer 1, correct?
Mm-hmm.
Now this in layer 1 what happens?
It is converted
Converts to
to
bits.
bits.
Bits. Frame is converted to bits. Now I'm considering this as wired connection. So the transmission is in the form of
Ethernet.
Electrical signals.
correct, electrical signals. Is this thing clear? Top to
Mm-hmm.
bottom. What is it called? It is called as encapsulation. The process from top to bottom is called as what? Encapsulation, right?
Encapsulation. Okay.
Why it is called as encapsulation? Because each and every layer is encapsulating its header,
Header.
correct?
Mm-hmm.
Now, what happens at the receiver's end? Decapsulation means opening
Decapsulation.
of each and every header happens, correct?
Mm-hmm.
Now, let me explain the same decapsulation starting from here. Now, the moment those bits are received to destination device, bits are received. These bits are converted to what? Frame, correct?
Frame. Mm-hmm.
Inside the frame, firstly, FCS happens, correct?
Yeah.
Once FCS is matched, means hash code is matched. He'll check what? Destination MAC. Is it for me or is it for someone else? If it has come for my MAC address, I'll accept it. Correct?
Okay.
Okay. Depending on the MAC
Yeah.
address, he got to know it is for him. Then what happens? It will check what? Type. Why it is checking the type?
Um,
To get to know whom to hand over the leftover data or
Data.
leftover payload, correct? So
Mm-hmm.
depending on the type 800, what it will understand, the leftover payload need to be given to which layer? Network layer, but
Network
which
layer.
Network
protocol?
layer.
Which protocol in network layer?
IP4.
IP
IPv4.
version 4.
IPv4
How it has come to know that it has to hand over that to IPv4 only? Why not IPv6?
So,
address.
depending on the type.
Yes, because the type value is
0x.
0x800.
Okay.
So
Mm-hmm.
800 means IPv4. So that is the reason how it came to know that it needs to hand over the leftover payload or leftover data to IPv4 only. Now, once it has hand over to IPv4, again, what happens here? Checksum, right? Each and every layer will have checksum, I told, if you remember. Checksum is done. Once the checksum is matched, then it will check destination IP address, whether it is coming for my IP address or any other IP address, correct?
Okay.
Then depending on the destination IP, it will get to know it is coming for me only. Then next field, what it will check? Protocol field.
Protocol. Uh-huh.
Why it is checking that? To hand over to which protocol in layer 4. Depending on this information, depending on the information of protocol, he'll get to know to which protocol I need to hand over the leftover payload in transport layer. So the value is 6. Hence, I need to hand over it to transport layer. Sorry, TCP, protocol TCP in transport layer. Now, it has hand over to TCP. Now, TCP will check what? Checksum again, correct?
Uh-huh.
Once the checksum is matched, then it will check what? Which port? Destination port.
Destination port.
If it is 23, so okay, he is asking for telnet. So in the application layer, I need to hand over the leftover data to telnet protocol in application layer, correct?
Uh-huh.
Am I clear?
Yeah.
Yeah, yeah,
Yeah,
clear.
yeah.
So it will provide the service as a reply to the PC. This is what is a flow. And this process which I have just now, this process is called as what? Decapsulation.
Decapsulation.
Okay. This is unwrapping of data, basically unwrapping of headers or unwrapping of data. Am I clear?
Yeah, clear.
Yeah.
So this is how encapsulation happens from top to bottom, and this is how from bottom to top decapsulation happens. Is the flow clear?
Yeah,
Yes.
clear.
Interviewer will ask in the same manner. He
Okay.
won't ask what is application layer, he won't ask what is presentation layer. He'll ask in this manner. What the people will forget, according to me, people will forget three-way handshake for sure. Why do they
Okay.
forget that? Because they assume this to be TCP, they'll directly start the header. Okay, you're directly starting the header. But firstly, three-way handshake happens. Only then the data exchange will begin. Correct?
Yeah.
Yeah.
You need to remember the basic key points. Now you need to brush up yourself with this flow, not the concepts which I have told. Concepts are just to understand what exactly is happening at the back end, why this concept came into between. Now you need to know how to apply those learned concepts into the real-time scenarios. This is how it is applied. Am I clear?
Yeah, it's clear.
Now starting from this day
Yeah.
onwards, everything will be most important thing. Reason why it is most important is whatever you have learned till now will be applied into real-time scenarios starting from this day onwards. Okay.
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 Now tomorrow we'll start with, not tomorrow, before going to tomorrow, there are certain things which I need to highlight over here. Firstly, this flow. Okay. Have you ever run this command firstly? Have you ever seen this?
Ping.
Yeah.
Uh-huh. Uh,
So
to
ping to
check.
any IP address. We are getting some reply, right? We'll
Mm-hmm.
understand the backend process of the ping firstly.
Okay.
Okay. Now, if I'll discuss it right now, it'll be around 1 hour or more than that, not sure. Okay. So I'll definitely discuss it tomorrow only. Let me think of the concepts for tomorrow. Firstly, I will discuss ping process. Here only you learn about ARP. Here only you learn about ICMP. Now, once these are done, we'll discuss about what is administrative distance, what is longest preface match. Hope we are done with subnetting concepts, right?
Yeah. Mm,
Um, metric. So these would be the concepts for tomorrow, but hopefully I may take more time in the ping, ARP and ICMP process, backend process of the ping. So again, I'm saying, please do revise these concepts because you were stuck in the questions which I was asking. Okay. And you can refer any of the videos. I challenge you won't find this much deep dive information. Have you ever tried to refer any videos from YouTube or anywhere else?
uh,
Mm.
Not even one video regarding OSI or something like that?
no.
I suggest you go through those videos. Reason why I'm suggesting, you'll understand the way they are explaining and you'll
Okay.
understand if any information is additional from there. And most possibly, I believe the explanation would be like using the devices if they explain because they have those devices. That's the only difference. I am explaining you on whiteboard. They'll explain with the devices, not in detail, but to some extent. Okay.
Okay.
And apart from this, mm, please do practice subnetting questions, sample subnetting questions. You'll have the answers as well. Okay.
Okay.
That would be your practice. As many questions as you practice, the more you'll become perfect with subnetting. Okay. Honestly, if you
S-
ask me, I know how to devise those subnets. I know the concepts.
Actually, subnetting topic, I think you did not cover yet. IP
Did not?
subnetting, IP subnetting you're talking about, right?
Correct.
Yeah, you did not cover that IP subnetting.
We have seen different classes, I believe, right?
Uh, mm, no, we did
Are
not
you
go
sure?
through that. Yeah,
How about you, Purna?
class. Yeah, yeah. I'm just saying. We only talking, not Ritesh.
Okay. How about you, Ritesh?
I'm not sure.
We did
Are
not
you
talk about these IP classes, like class A, class B. You're talking about those, right?
correct?
No, we did not go through in this class, like any of these classes.
Okay, sure. So for my reference, please go through the previous videos if
Okay.
they are shared with you.
Yeah, they are shared, like
Have you
previous
gone through
videos.
second
Yeah.
video
Yeah.
completely?
Not completely, but yeah. I got to the main points. I didn't hear anything like IP, whatever he said, types, A or B.
Subnetting, yeah.
No. ARP is tomorrow's class. I'll cover up everything
No,
in
no.
tomorrow's
IP
class.
subnetting he's talking about, so we
Okay.
haven't gone through that.
No
Okay.
worries. I'll discuss it. Whatever the doubts, no worries. I'll discuss it one
Okay.
more time as well. But
Okay.
somewhere I have explained to your batch or to some other batch. I don't really believe. I mean, to your batch only, I guess.
Okay, we'll just go through once
Go through that
again. Like,
video. I
yeah,
believe
okay.
somewhere there is concept might be there. Submitting. I think I have explained you the classes. Multicast
Okay.
address in the first. How many videos covered so far?
Like,
Oh,
do
this is
again.
third one.
This is third one, yeah.
Third one, right? So second video should have the information possibly.
Okay, we'll go through once again.
Please go through it daily basis because please go through it on daily basis. Reason why on daily basis is to make notes. If you make notes, right, you don't have to go through the video again because
Okay.
videos will take long time.
Mm-hmm.
Once you have notes handy, then you'll save a lot of time.
Okay.
Mm, and what else I was? What is the RAM? Do you have laptops with you?
Yeah, yeah.
What is the RAM in your laptops?
Mine is 8.
And yours, Ritesh?
Yeah, 8.
Yeah, that should be enough. Mm, have you downloaded Wireshark?
Yeah, I did.
Okay, fine. That should anyhow work. How about VMware and these things? Okay, I'll do one thing. Let me install first those softwares and I'll suggest how you should install those things and all. No worries. But you'll have virtual lab setups
Okay.
and practical sessions you need to practice in those virtual lab setups only. I believe free tools would be one would be Packet Tracer, I believe. Yeah, Packet Tracer is of free.
For
And
using switching and routing, I
yeah,
mean switches, and then packet tracer is free.
mm, Packet Tracer is one. Then GNS is other tool which is available, but the GNS eats up lot of your RAM. Okay,
But the iOS is not free, right? For GNS, is
no,
it free?
it is free.
Okay. Okay.
Mm, if not, I'll see if I have any softwares or something like that. I actually my PC was having some issues, so I have
Okay.
formatted it. So that's the reason why I've lost all the device access or uh, all the virtual setup access. I need to set up again, but I'm not
Okay.
finding time to set up that. Hopefully, for your batch, I need to set up as early as possible, just to because from today onwards, with this topic which I've discussed, on this topic onwards, we have entered into live scenarios, real-time scenarios, and we'll take the help of Wireshark to troubleshoot the issue as well. How the issue is troubleshooted exactly. And so far, any doubts or any questions?
Um, right now, no.
So
I most probably
your voice is
I have
breaking
to
up.
ask you. I
Go
have to
ahead.
ask you about like encryption, like encapsulation and decapsulation. Like I have like not properly understood everything, so I have to like go through it once more. And if I have any doubts, I'll like come back to you tomorrow.
Okay, no worries. See, whenever you're watching the video, please
Mm-hmm.
understand my way of explanation. Meaning, my explanation not only is explaining it to you, but to understand how it actually works. Uh, if you observed carefully, I was putting questions and then answering those. How it is functioning, why is this functioning. I'm not sure whether
Yeah.
you have observed that thing or not. Why the three-way handshake came over here. I was saying in that manner. Okay, I was explaining in that manner. Why it is layer 7? Because this is layer 7 protocol. It is dependent on which service. In that way, I was explaining. Okay. In the same way, you need to write the notes as well. Why? Then answer. Why? Then answer. Why? Then answer. Then you will not forget, because that would be a logical approach. And interviewers in the interviews, they'll not expect exact answer.
Okay.
They'll expect only the logical thinking.
Okay.
And not only that part, but why the logical thinking is important, because your way of troubleshooting is different, my way of troubleshooting is different. But whatever the way you troubleshoot, irrespective of the way you troubleshoot, main thing is the resolution. How, which step is your resolution step? Meaning, for me, the fourth step is resolution step. For you, it could be third step. For other person, it could be second step out itself. Depending on the knowledge, depending on the experience, depending on the logical analysis which he has. Am I clear?
Okay.
Yeah.
So in that way, you need to proceed. Here, networking is all about logical understanding and troubleshooting the things. Uh, If you ask me how networking to be understood by us is three simple things. One is to configure. Next thing is to verify what you have configured. Third thing is to troubleshoot if there is any, if there are any mistakes. Am I clear?
Okay.
Yeah.
Always remember these three things. You only need to configure, you only need to verify, you only need to troubleshoot. If you ask me how to learn networking, is to make mistakes and then learn it. What happens if you configure a wrong IP address? What error you'll see in that case? Bookish
Okay.
knowledge is written by someone only. But if you learn by yourself, you'll never forget it. This is what is my assumption. Am I clear?
Yeah, it's clear.
Yeah.
Okay.
So don't believe on books, because many concepts from the books is as per the devices which they have seen. It is not applicable on all the devices. It is applicable only on some of the devices which the author has seen practically. Am I clear?
Yeah.
Yeah, understood.
So that thing you should keep in mind always.
Mm-hmm.
And you don't have to argue. See, in the book it was written like that. No, it is written by someone who has experimented on one particular device, but not on all the devices. Remember that thing.
Okay.
Okay.
Okay. Okay then. we'll wind up for today. If in case you don't have any doubts, shall we?
Yeah,
Yeah,
sure.
we can.
Sure. Okay, then thank
Thank
you
you.
so much. Bye
Thank
bye.
you. Bye.
Take care.